Hello everyone, this is Hacker on Call. Today I'll go over IDS Fundamentals on TryHackMe, which is a premium room, which will go over intrusion detection systems and how we can use Snort for that. So let's start with task 1. In the previous room, Intro to Firewall, we studied the role of the firewall, a security solution used to deploy on a boundary of network to protect its incoming and outgoing traffic. The firewall checks the traffic when connection is going to take place and denies it if it violates the firewall rules. So yeah, there are different type of rules. The new generation firewall, stateful and stateless firewalls. We covered that. However, there should be some security to detect activities to connection that pass through the firewall if already taken place. So if the attacker successfully bypasses a firewall via legitimate looking connection and then performs any malicious activities inside the network, there should be something to detect it timely. For this purpose, we have security solutions inside the network. This solution is known as an intrusion detection system. Take an example of a building security. A firewall acts as a gatekeeper, checking the people coming in and outgoing. There is always a chance that some bad actor that will successfully sneak inside and start performing malicious activity. He was missed at the gate, but if we catch him, even if he gets in, it can be done by surveillance cameras presenting throughout the building. The IDS intrusion detection system plays the role of surveillance cameras. It sits in a corner monitoring the network traffic based on its signature and anomalies-based detection, and detects any abnormality traffic going out or inside the network. Upon every detection, an alert is generated for the security administrators. The IDS does not act on those detections. It only notifies the security administrator about the anomaly or malicious activity. So have a diagram of whatever this is. Okay, this room will equip you with some knowledge of intrusion detection solutions, and the upcoming task will also explore the most popular open IDS solutions. Learning objective, types of intrusion detection system and their detection capabilities, working with Snort, default and custom rules in Snort, making a custom rule in Snort. Can an intrusion detection system prevent the threat after it detects it? Nope, it cannot. It only detects it. There is an intrusion prevention system. That's a different one. Type of IDSs. Intrusion detection system can be categorized differently depending on certain factors. Each ID's main categories depends on deployment and detection modes. Deployment modes. IDS can be deployed in the following ways. Host intrusion detection system. Host-based intrusion detection systems are installed individually on the host and they're responsible for only detecting potential security threats associated with that particular host. Some provide detailed visibility of the host activities. However, host intrusion detection systems can be challenging to manage in a large network as they're resource intensive and require management on each host. Although you can do that with different IT management resources. It's not actually that hard. It depends on your skill level. Network intrusion detection system, NIDS. Network-based ID solutions are crucial in detecting potential malicious activities within the whole network, regardless of any specific hosts. To monitor and the network traffic of all the hosts involved to detect suspicious activities, it provides centralized view of the detection inside the whole network. So host intrusion detection system and network. So both have the same firewall, but then it stops on a single computer, single instance, but then we have it here as a server that monitors all the traffic. Detection modes. Signature-based detection modes. Many attacks occur every day. Each attack has its own unique pattern, which is known as a signature. These signatures are presented by the IDs in their databases so that the same attack happens in the future. It gets detected by a signature and reported to the security administrators for action. The stronger the signature database of IDs, the more efficient it would detect known threats. However, the signature-based IDs are unable to detect zero-day attacks. Zero-day attacks have no prior signatures or patterns and are not safe inside an IDS database. Therefore, the signature-based IDS can only detect the attack that happens previously, and its signatures patterns are safe inside the database. In the upcoming task, we'll explore signature-based database named Snort. Anomaly-based IDS. This type of IDS first learn is a norm. This type of IDS first learns the normal behavior or baseline of a network system and performs detection if there is any deviation from the normal behavior. Anomaly-based IDs can also detect zero-day attacks because they don't rely on the available signatures for the detection, but detect abnormalities inside the network or system by comparing the current state with the normal behavior baseline. However, those type of IDs may generate lots of false positive, marking banning activity as malicious. Because of the nature of most legitimate programming machines, the malicious ones. Anomaly-based IDs or ID would mark the malicious as a behavior usually as malicious. Wait, what is it? Anomaly-based IDs would mark the malicious and believe anything behaving unusually is malicious. We can also reduce the false positive generated by anomalies by IDs by fine-tuning it, manually defining normal behavior of the IDs. Hybrid IDs. A hybrid IDs is a combination that detects method signature. It combines the detection method of a signature-based IDs and anomaly-based IDs to leverage the strength of each approach. Some known threats already have some signatures in the IDs database. In this case, we use the hybrid IDs would use the detection technique of a signature-based IDs. If it encounters a new threat, it can leverage the detection method of anomaly-based IDS. Signature-based IDS can detect threats quickly, while other IDS can have high processing overhead. However, it's also essential to consider IDS based on several different factors. Signatures-based IDS can be a good option for covering a small threat surface. Anomaly-based IDS and hybrid IDS can help detect modern zero-day attacks, which are increasingly daily and can cause massive damage to organizations. Which type of IDS is deployed to detect threats throughout the network? Network base. Is it network intrusion detection system? Network intrusion detection system, yeah. Which IDS leverage both signature-based? Hybrid. Hybrid IDS. Perfect. Okay, IDS example Snort. Snort is one of the most widely used open source IDS solutions developed in 1998. It uses signature-based and anomaly-based detection to identify known threats. These are defined in the rule file of the Snort tool. Several built-in rule files come pre-installed in a tool package. This built-in rules file contains a variety of known attack patterns. Snort built-in rule can detect a lot of malicious traffic to you. However, you can configure Snort to detect specific types of network traffic that are not covered by the default rule files. You can create custom rules based on your requirement to detect specific traffic. You can also disable any built-in detection rules if they don't point to harmful traffic for your system and network, and define some custom rules instead. In the upcoming task, we'll explore the built-in rules and make custom rules to detect specific traffic. Packet sniffing mode, packet logging mode, and ID and NIDS mode. It was network intrusion detection system mode. So packet sniffing mode, this mode reads and displays network packets without performing any analysis of them. The packet sniffing mode of Snort does not directly relate to IDS capabilities, but it can be helpful in network monitoring and troubleshooting. In some cases, system administrator might need to read the traffic low without performing any detection to diagnose specific uses. In this case, they utilize the packet sniffer mode of Snort. This mode allows you to display the network traffic of the console and even output in the file. The use case is the network team observes some network performance issue. To diagnose the issue, they need detailed insights into the network traffic. For this purpose, they utilize snort packets in the sniffer mode. Okay, so we have a packet logging mode. Snort performs detection on a network traffic in real time and displays detections as alerts for the console and security administrators to take action. However, in some cases, the network traffic needs to be logged for later analysis. The packet logging mode of Snort allows you to log the network in a traffic of a PCAP file, standard packet capture format. This includes all the network traffic and any detections from it. Forensics investigators can use the Snort log file to perform the root cause analysis of previous attacks. And the use case is that the security team needs to investigate a forensic investigation of a network attack. They would need the traffic logs to perform the root cause analysis. The network traffic log through Snort's package logging mode can help them. Mode network intrusion detection system mode. Description: Snort's MIDS mode is the primary mode that monitors network traffic in real time. It applies its rule files to identify any match for known attack patterns stored as signatures. If there is a match, it generates an alert. This mode provides the main functionality of IDS solution. In the use cases, the security team must proactively monitor their network or systems to detect potential threats. They can leverage Snort's NIDS mode to achieve this. The most relevant use of Snort as an IDS comes from NIDS mode. However, Snort can be used for any of the above modes depending on their requirement. Which mode of Snort helps you log network traffic in a PCAP packet logging mode? What's the primary mode of Snort called? It's network intrusion 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 detection system mode. Perfect. Then we have practice with Snort. Amazing. During Snort installation, you must provide your network interface and range. You can run Snort normally, where it only captures the traffic intended to the host. However, if you want to use Snort to capture and detect intrusion to the whole network, you must turn promiscuous mode on your host network interface. First, let's start with virtual machine. By pressing OK, we start the virtual machine. Snort has some built-in rules and configure files and other files. They are stored in etc/snort directory. The key file for the Snort is configuration file snort.conf, where you can specify which rule files to enable and which network range to monitor and enable other settings. The rule files are stored in the rules folder. Let's use ls command to list down all the files and folders presented in Snort's main directory. Okay, so they're basically going to listing all the etc/snort files. So they see classification.config, reference.config, snort Debian. Okay, rule format. Now let's discuss how rules are created in Snort. There is a specific way of writing the rules. Following a sample rule that will detect ICMP. Was it mail protocol or something? Whatever. Packets usually used when you ping a host. Okay, allow coming from an IP address and a port and reaching the home network. The network ranges is defined as Snort configuration file on any port to any port. Once the traffic is detected, it generates a ping detected alert. So we see alert ICMP source source port to destination IP, destination port, rule metadata, message, what we want to display, signature ID, what should be the signature of it, rule revisions. Okay, the basic how it's done. Okay, let's check it out on our computer. So let's ls the etc /snort, and there we go, we have them. The details of the components involved in the rules are given. Action specifies which action to take when the rule is triggered. In this case, we have the action alert when the traffic matches the rule. Protocol refers to the protocol that matches this rule. In this case, we use the protocol ICMP, which is used when we ping a host. Source IP, okay, we just specify source IP. Source port, same thing. Destination, where it goes. Specify the destination be which match traffic comes. Okay. Okay. Destination port, sure. Rule metadata. Every rule has its own metadata. This is defined at the end of the rule's parentheses. The following as the components of the message describes the message can be displayed when the subject triggered. The message should indicate the type of activity detected. Okay, sure. Signature. Every rule has its own unique identifier that differentiates it from the other rules. This identifier is called the signature ID, SID, or SID. In this case, the SID is 10,001. Rule revisions. This sets the revision number of this rule. Every time the rule is modified, the revision number is incremented. This helps track of the changes to any rules. Okay, rule creation. Let's check it out. Let's paste the sample rule explained above into a custom local.rules file in the snort files directory. Where is it? Local.rules. Oh. Okay, so it's sudo vim and let's go to rules. What do you mean? There's let's see. Let's do to etc. Snort. Okay, we're in snort. Let's go to the rules and then sudo vim local.rules. Perfect. Okay, a new one. Now add the following. So we want alert ICMP any port, any IP, any port that goes to 127, which is our local one. Any port with a message loop back ping detected SID of 10,003. Is it 10,003? Yeah, 2003. And then the revisions 1. Perfect. We'll need the other. We need the other already present rules in the stack, so do not delete them. Once you successfully. Okay. Perfect. Rule testing. Let's first start snort tool to detect any intrusion defined in this rule file. For this, we have to execute the following command with sudo privileges in our console. So we'll do sudo snort q l /var /log /snort I lo -a console c etc snort.configure. Perfect. this case, your loopback interface is called LO. Replace the correct interface. Wait. In case of loopback interface, it's not called LO. Replace it with correct interface. What do I do by this one? I'll come back and I'll check this one out. So basically try pinging that and we get alerts. Yep. Screenshot below shows the snort generated loopback ping detected. Yeah, that's the alert that we got, and that's the rule that we configured some time ago. Running snort on the pickup files. We saw how snort can be used for intrusion detection on real-time traffic. However, you may sometimes encounter a scenario where you have historical network traffic locked in a file, and you have to perform a forensic investigation to determine any signs of intrusion through that traffic. That traffic is usually logged in the standard packet capture file, a PCAP. Snort is also equipped with perform detections on these PCAP files containing historical network traffic. Okay, perfect. To allow command with pseudo privileges can be used to perform this action. Okay, we'll close this terminal. We don't need it anymore. Let's see. Close snort. Sudo snort q l /var log snort r. Task. I'm feeling that, yeah, I'm feeling it should be one level higher than I am currently located. I think I should be like here. Task dot something. Or which PCAP? Intro to IDS PCAP, right? Where is the main directory of snort? It's /etc snort. Which field in SAR rule indicates the revision? It's the rev. Which protocol is defined in the sample rule created in this task ICMP? What is the file name that contains custom rules for snort? Was it rules.conf? No. Or maybe it's a city rules. What is the file name that contains custom rules? Oh, hell no, I forgot. Snore.conf? No. Local.rules. There you go. And how does this one work? Okay, we're given snore, search console. Sure. Just copy paste that shit command. Practical lab, finally. Finally a practical lab. So now you're a third-party forensic investigator. Company contracts to investigate a recent KKK intro to PCAP, which contains the network traffic captured during the attack. Your task is to run snort in that PCAP file and answer the question given the task. The PCAP file intro to this. Okay, we have it. Okay, let's run the command they have here, which is basically is let's see, sudo snort when it's for privileges q l /var/log/snort. I actually wish they tell us what those commands mean. R intro to pcap, a console, c etc /snort/snort.conf. Okay, let's see. And we get a very big output, or not very. So let's answer some questions here. Practical lab. What is the IP address of the machine that tried to connect to the subject machine using SSH. SSH. Connection detected. This is the IP address. 10, 11, 90 to 11. Yeah, that's correct. Okay. What other rule message besides the SH message was detected in the PCAP? SSH, what else is there? Ping, ping, ping detected. What is the SID of the rule that detects SH? That's good, that's good. Uh, yeah, that's a good idea. Uh, Interesting. Priority 0, etc. Where do I check? Oh, I see, it's this one. Is it? No, no, it's not. I just go to the config file, or do I just... Okay, no, it's not. That's the port of the IP address. Oh, that's the ID. Or it was... I think that's the ID, or it makes sense to me to be ID. So 100,002. No. I... No, what is it? 1 and 5 zeros. This? Yeah, that's the city. Okay, finally completed this, and see you guys in another video. It was Hacker on Call.